Experimental and numerical investigation of the flexural behavior of green ultra-high performance fiber reinforcement concrete beams under repeated loads by Ayman Abdu, Ramadan Askar, Dina Atif, and Said Ahmed. Introduction. Green ultra-high performance fiber reinforcement concrete is a new construction material with high compressive and flexure strengths. Green ultra-high performance fiber reinforcement concrete is environmentally friendly concrete, which replaces the amount of cement by any waste like fly ash. The impact of utilizing green ultra-high performance fiber reinforcement concrete on the flexure behavior of certain beams was investigated experimentally and numerically under repeated loads. The major parameters of the study were fly ash replacement ratio of 15%, 30%, and 45%, and adding steel fiber to mix with ratio of 1, 2, 3, and 4%. The tested beams were compared to the control beam in their backbone and hysteresis curves, failure load, crack progresses, and failure mode, energy dissipation, stiffness, degradation, and ductility. Figure of beams. Objectives. Improve the concrete to environmentally friendly concrete by replacement the cement by any waste as fly ash to produce green ultra-high performance fiber reinforcement concrete and applied it in structure element. High compressive strength, flexure strength, repeated load. Conclusion. Based on the result of experimental work and numerical work, from this figure it is recommended to use fly ash with a replacement ratio of 45% from cement and steel fiber with a volume fraction of 2%. The failure mode for the tested beams was due to the concrete crushing in the compression zone. The steel fiber slows the spread of cracks and gives the beam flexure strength. Increased steel fiber proportion causes a reduction in cracks. Figures of failure mode. The ductility factor decreased with increased volume fraction. The ductility factor decreased by 21%, 8%, 18%, and 15% for beams containing 1%, 2%, 3%, and 4% fiber, representatively comparing to the control beam. The ductility factor decreased with increased fly ash up to 45, with fiber content of 2% have the largest ductility factor after control beam. The initial stiffness for the first cycle increased with increased volume fraction up to 3%. The initial stiffness increased by 25, 58, 93, and 63% for beams contain 1%, 2%, 3%, and 4% fiber. 3% fiber and 15% fly ash content have the highest stiffness compared to control and other beams. Figures of stiffness. Total energy dissipation increased with increased volume fraction up to 2%. The total energy dissipation increased by 10, 38, 14, and 11% for beam contain 1, 2, 3, and 4 fiber. The total energy dissipation increased with using fly ash up to 30%. 2% fiber and 30% fly ash content have a highest total energy dissipation compared to control and other beam. Figures of total energy dissipation. This is a great agreement between experimental and numerical result. From the result obtained, environmentally friendly concrete green ultra-high performance fiber reinforcement concrete can be produced by replacement cement with fly ash up to 45% and adding 2% steel fiber.